So today we're going to be continuing learning how to use the CNC programming tools within Creo. There's a first part to this tutorial which you should do before you begin this video, so this is part 2. But just for review, I've got the first part tutorial that you will need to work through here. So there's a link to this in the Blackboard site, and essentially what we do is we bring in a copy of our mold design and we set up a CNC manufacturing assembly, and then we do some machining on that assembly. So I'm just skipping through to various points within that video. But you're really going to need to work through that video first. And then by the end of that video, we've created what are referred to as numerous machining sequences or milling sequences to actually allow us to remove the material and create our mold, essentially. So we begin with a solid block of material represented by this green cuboid, and then eventually we're hoping to machine material away so that we end up with our mold shape. And the sequences that we end up creating, there's 3 of them. There's a face mill here, sequence 1, a roughing pass here, sequence 2, and then a volume milling pass here, sequence 3. So that is what we achieved by the end of that first session. So I'll just get rid of that for a second. So in order to continue from the same point, I've actually provided the files that we're going to begin work on. So you won't need to make a copy of your files from part 1. I've actually provided them. And they're in the appropriate area on the Blackboard site, so they're in the area entitled CNC Programming in Creo, and the files that you're going to need are inside that zip file there. So I've called the zip file CNC Continued. So you'll obviously have to download that zip file and then unzip that zip file into a folder, and then I've done that. And I've got a folder now called CNC Continued, and it has the required Creo files in that folder. So you can see there's some part files, volume 1, there's mold CNC work, there's a part file, there's the overall assembly file, and then there's some other files that Creo saves specifically when you're working with CNC assemblies. So you're going to need to set that directory, that CNC Continued directory, as your working directory. And when you do, you should be able to browse into there and open up the assembly which is called Mold CNC ASM. And when you do, you should be looking at something very much like what I'm looking at on the screen here. So as I loaded that in, I turned off some of the display of some of the datum items. So you can see that I've turned everything back on. What is most useful to us here is to be able to see the planes, certainly, and everything else you can just turn the visibility of it to off like that, so it tidies up the display a little bit. So what we're going to be doing is we're going to be adding some more milling sequences to this CNC assembly, and hopefully get nearer and nearer to our finished part. In this case, our half of our mold cavity. So before we get started on that, it's probably a good idea just to review where we got to in terms of the machining of this mold half last time. So in order to do that, we can run a material removal simulation on all of the sequences that we've created, and the way that we do that is go up to the operation level here above the sequences, and if we click on Op 10 we can then do a material removal simulation. So we click there. It'll take a couple of seconds just to calculate that, and then if we click here to get our player controls for our simulation, and then if I click play, I can watch those 3 sequences taking material away from my stock block that I started with. So that's essentially what we've created at this point. So we've obviously got a lot of material to take out of the main internal cavity here, and if we want to get a rough idea as to how much extra material there is to remove, one of the tools that we used last time was the compare tool in this material simulation, and when we click on compare in there, we're essentially seeing a color-coded visualization of areas which are largely finished, so those would be the green areas here, and areas which have quite a lot of material still to remove. So you can see the rainbow plot up here. The areas that I've just described as more or less finished are within a quarter millimeter, either plus or minus, of their finished shape, and the areas in blue are somewhere above 1 millimeter. So 1 millimeter to infinity is the distance that they are away from their intended finished shape and dimension. So we've got quite a lot of material still to remove. So I'm just closing this simulation down. So I close the player controls down, I close the simulation itself, and now we're ready to create some more milling sequences. So the first sort of milling sequence that I'm going to create is the same as the last one that we used at the end of the first part of this tutorial, the introduction. So it is going to be a volume mill, a volume milling sequence. And as we saw last time, in order to create a volume mill, you have to create some manufacturing geometry first. And we can see the manufacturing geometry that we created for the volume mill from part 1 of this tutorial. There it is. So it was just a simple extrude. So I'm just going to recap that technique, but for a slightly different area of the part this time. So what I'm going to do before I create this mill volume, this type of manufacturing geometry, is I'm just going to hide the workpiece. And often you will need to hide and then show the workpiece, because sometimes it can obscure your ability to click on areas of the reference model. So it's an easy thing to do. We just find the workpiece in the model tree, click on it, and click on the hide icon like that, and it will disappear until we click on it again and click on the show icon. So what I'm going to do is I'm going to tell the system that I want to create a mill volume. I'm going to use the extrude tool again, although I could use a revolve or a sweep or any of these other sorts of standard modeling tools. So I'm going to say I want to create an extrude, and then what the system's asking for is a sketch, is some input to create this extrude. So if I click on the placement tab, I can see it's waiting for a sketch. That's why this red dot is there. It's waiting for some input. I don't have a sketch currently, so I'm going to define one. Then I have to select a sketch plane, so you can see that this box is highlighted in green, and I'm going to sketch down in the cavity on the flat face of the bottom of my cavity shape. So that face there. Then it's looking for a reference, so again it's happy that I've chosen a sketching plane. It needs a reference. I'm going to use one of these datum planes as my reference, so maybe the overall plane of the assembly. Actually this is the vice plane. Let's find the assembly plane right there. And as I view my sketch, do I want to regard that plane as the top of my sketch, the bottom of my sketch, the left of my sketch, or the right of my sketch? I'm going to choose left and see what that gives me. Yeah, that is fine. So now what I'm going to do, I'm not actually going to manually create this shape in this sketch. I'm going to steal some geometry from the reference model itself, so from the mold itself. So I'm going to use the project tool, which we've used many times before to copy geometry into a sketch. So project, and it's a loop that I want to copy into this sketch or steal. So loop, and it's the bottom face that I'm actually creating the sketch on. I want a copy of that in the sketch, so I'll just click and it traces the outside edge of that face, and then I'm happy. I don't want to create any more geometry within this sketch, so I'm going to just click on OK to OK the sketch. Then I'm going to rotate my view a little bit just to see what I'm doing a little bit better. And at this point I've got to kind of reason how high I would like this extrude. And seeing as previously I know that I've machined down to the level of this blue surface here, it would make sense not to have this volume extend upwards beyond that surface. So what I'm going to do is change this extrude from a blind value that I enter to a to selected extrude. So if I click on to selected, and then if I click on the surface or edge or point that I want to extrude to, it's this blue surface that I want to extrude up to. So click, and then the extrudes up till it's coincident with that surface and then stops. And then I'm happy with that extruded shape, so I'll click on OK. So now I've created my mill volume, but this is a tricky step that we saw last time. I'm still stuck in the mill volume tab, so I have to make sure that I OK the mill volume. So the green tick in the mill volume menu is quite small, it's quite easy to miss, but you must OK that mill volume before you can get back and create your mill sequence in the mill menu. So I'll OK the mill volume, click, and now I can begin creating my milling sequence using that volume as my reference for what material I want the sequence to remove. So now I'm going to create my volume rough sequence using that manufacturing geometry, that mill volume that we just created. So I want to create a volume rough. I have to put certain info in here in order to generate a toolpath. One of the things that I need is a coordinate system, but the system is happy to auto select that for me. Another piece of data that I have to put in is the tool that I want to use. Now this is defaulted to the last previous tool that I used to do any machining, and in this case I'm going to decide that I don't want to use that tool. I want to create a new tool for this operation. So I'm going to click in the drop down list, go into my tool table by clicking on edit tools. So here's my tool table, and I'm going to create a new tool. So I'm going to click here to create a new tool, click, and then I'm free to set the geometry of my tool or the type of tool. So I want a flat end mill, so just a standard end mill. I want the diameter to be a little bit narrower than I've used before, so maybe 10 millimeters. 100 millimeter extension is okay. I'm going to say that the cutting flutes extend 60 millimeters up. And I'm going to put a typical holder on this. So I'm going to make this holder 60 millimeters tall and 45 millimeters wide. And then if I want to get a preview of what that sort of geometry looks like, I can click there to display a preview, and it looks something like that. There it is with the holder included. So I want to apply this tool, so I'm going to click on apply. Just before we come out of the tool table here, one thing that we haven't tackled up to this point, but we will begin to talk about it and think about it as well, is that as we've created these tools, the only data that we've entered really is the tool type, so in this case it's an end mill, and the actual geometry of the tool itself. So things like the diameter of an end mill and the length of the end mill which is sticking out from the holder, the diameter and the length of the holder, and the diameter, the length of the cutting teeth or the cutting flutes of the tool as well. So these are all things related to the geometry of the tool. But hand in hand with that is how quickly the CNC machine that this program will be run on will move that tool around. So how quickly will it spin it in terms of revolutions per minute or RPM? How quickly will the tool be moved in X and Y directions? So those are the two horizontal directions that our 3-axis mill can move in. And the place where we set all these sorts of figures or quantities are in the cut data tab. So we haven't been in here up to this point. So you can see we can set the speed in revolutions per minute or RPM. We can set the feed in millimeters per minute. And we can set various other ones, but those are the two big ones, the speed and the feed. And we'll talk about a little bit later, or I'll show you certain places on the internet that you can obtain this cutting data. So what we've been doing up to this point, we haven't been entering anything in those cut data boxes, so that when we click on OK and we generate our preview of our toolpath, what the system is doing is it is looking at the type of tool that we've selected, it's looking at the geometry that we've input, it's looking at the area of material that we are trying to clear or machine away, and it is coming up with what it considers sensible values for the speeds and feeds. So currently we don't have any control over it, but we can have control over that. We can either edit it in the tool menu, so we can set feeds and speeds per tool, or we can actually edit it in the milling sequence menu as well. So you can set your speeds and feeds. There's the cut feed, there's the spindle speed in RPM. You can set them actually in each milling sequence as well. But we won't do it for this sequence, but we will look a little bit later on when we're creating other sequences, how you might get that data or research that data, and then we'll enter it in some of these boxes. So there's one last input that this sequence needs before it can generate a toolpath for us, or before we can simulate it, and it's in this references tab, which is why it's highlighted in yellow. So click on reference. What is our machining reference? Well, it's our volume that we previously created to mark out the area of material that we want to remove. So click, it accepts that volume, and at this point we can see the toolpath. If we click on the toolpath preview here, so click, there's our toolpath. It's taking the material out in various slices, so you can see it kind of dropping down and moving around to create a slice of material that it takes, and then it drops down a bit further and a bit further and a bit further and a bit further. If we want to know how far that is dropping down each time, we can go into parameters. So the step over is 5, but the step down, or the max step depth, is 1. So if we decide our 10mm tool can take greater depths of material out, we could maybe increase that to, let's say, something like 3. And then when we click out of the box with 3 in, the preview will update. So you can see a sequence such as this will take a lot less time than the original one that we had when this value was set to 1mm step depth. So obviously there's a lot more movement there to take out the same amount of material than if we increase the step depth by 3. Then the cutting time should reduce to 1/3, or approximately 1/3 of what it was before. And again, Step depth is linked to spindle speed and cut feed and step over, but we will look later on as to where you will get sensible figures for all of these values from online tool manufacturing websites. So at this point, if we're broadly happy with that sequence, we can click on OK, and then if we want to simulate the entirety of all our sequences one after the other and watch them actually remove the material, then the first thing that we have to do is show our workpiece again, so that our material removal simulation will also show the workpiece. And then if we click on the operation level above all the sequences here, so op 10, we can run a material removal sim. Again, it takes a second to calculate. And then before I actually run this simulation, I'm going to set some options. So I'm going to change the stock display from regular to sequence. And I think for the time being, that is okay. We'll leave that one change, and we'll talk about what that did when we run the simulation through once. So I'll get the simulation player controls visible. Just before I press play, I want to browse into this little window. Sorry, not that one. This little window here. So I have 4 sequences that are going to run one after the other. I'm going to press play, and I will watch the tool removing the material now. One thing that you will notice is that the cut faces have now been coloured in a different colour. So the thought here is that each sequence has its own colour. Now it's a little bit hard to tell this yellow colour from this yellow from this orange. So what I'm going to do is I'm going to modify one of these by double clicking on it. Maybe turn this one so it's bright pink. And then maybe I'll double click on this one and turn it so it's kind of a bluey colour. So you can see now more clearly the areas that were cut in each sequence. So you can see the original face mill the material that cut away has been kind of overwritten by the roughing pass that we did in blue. So the roughing pass cut away all this material round here. The only remnants of the face mill, which is this orange pass, is the tops of these 2 little islands here. And then the volume mill that we just completed, that we just did a second before, that will be the pink area here down inside the cavity. And then that original volume mill that we did in the last tutorial, that would account for this yellow area here. So you can colour the cut material by sequence or by tool. It depends which is more useful for you to be able to visualize. But if you don't set either of those 2 options, you don't get any color on the part at all. So it's all colored the same default kind of pink color. So yeah, that's quite a useful setting when you're visualizing the cut material. So just before we exit this, let's do a compare again. And now you can see that because we've machined down to the bottom of that volume that we created, down onto the bottom face of our cavity, that is now marked in green. So we can essentially regard that as finished, the bottom face. We still have material to take out on these kind of curved faces, but we'll tackle that in one of the coming sequences that we're about to create now. So I'm just going to shut the sim down there, and now I'm ready to create a new sequence. So in this next milling sequence, we're going to address the material which is around the sides of our reference model. So if you remember back, we added a distance of material around all sides of our reference model. And now we want to remove that. So it's these side faces essentially that we want to address, and we're going to use a sequence known as a profile mill because we're going to mark out a profile shape for it to follow around the outside of our part. Now the profile mill doesn't require a preceding step where you create manufacturing geometry. So some of these milling sequences require manufacturing geometry to be created before they can be set up, and some of these milling sequences don't require that, and profile mill is the one of the type that does not require any manufacturing geometry to be created first. So if we select profile mill, and then again the system will auto enter the data that it can into these selection boxes. So it's chosen our coordinate system already for us. It's chosen one of the existing tools. In this case I'd like to use a slightly larger tool, so I'm going to go in and edit my tool table again, create a new tool by clicking here, and this tool I want a relatively large diameter tool, so 25 100mm long is fine. Again, let's say the flutes are 50mm high, and then let's put a holder on this of 60 and 60, and then click apply. So OK, it's still waiting for some input from me in terms of the references tab. That's why the references tab is highlighted in yellow. So if I click on the references tab, and then I've got two options here. I can either select a previous step that I want to use as a reference, or I can select surfaces from the part itself, and in this case I'm going to select surface. And at this point I want to be able to select the outside edges of my reference model, but the system is defaulting to allowing me to select the outside of the workpiece. So I'm going to hide the workpiece again, like we just did in the previous example. So there's the workpiece in my model tree. I don't have to quit out of this profile milling menu. I can just right click, long right click that is, and select hide. And then I think I inadvertently added a reference in here, so I'm just right clicking in this box and saying remove anything that you already have, and now it's clean, that box, and it's ready for me to start selecting the surfaces that I want to machine to using this profile mill. So it is these outside surfaces of the reference model itself. So I'm holding down Control as I click here, so hold Control, click. Then I'm letting go of Control, and then I'm rotating my view to the other side of the reference model, and then I'm holding Control and clicking, keep Control held, and click one last time, and those are the surfaces that I want to machine away. So I'll try doing a toolpath preview. So here's my toolpath, click there, and that is the toolpath that I'm going to generate. So at that point I can do a material removal simulation, but in order to do that I want to run all the sequences that I've created end to end so that I can see the material being removed for all of them. So I'm going to temporarily OK this sequence to get out of the sequence menu. I need to bring the visibility of my workpiece back again, so I need to click on workpiece and show the workpiece, and then I can go to the operation level here above all the sequences and run my material removal simulation. So click, always takes a second just to calculate, and then I'll set my stock display again to sequence, and then I'll get my player controls, open my sequence list. If I want to change the colours here I can, like we did last time. In this case I'll not bother, and I'll click on play. So you can see the sequences running through. And what I'm interested in is the profile sequence towards the end of these sequences. So the tool will change to a much bigger diameter. There it is. So I've just paused it by clicking on the stop button, and what I'm going to do is reduce the speed down because I want to watch what is happening on this sequence specifically. So it's taking slices from the part, it's stepping down, and then if I can just catch it at the right point, so it appears as if it's passed straight through the vise there, and if I go into the drop down here which says collision report, it actually has. And if I double click on any one of these, the simulation will rewind to the point where the tool and the fixture collided. So I can double click on any one of these. So I'm obviously going to have to modify my tool path in some way to avoid these collisions. So that can be useful, and sometimes what you can see is the fixture glowing red as the simulation is actually running. But if you suspect there is a collision, it's a good idea to check the collision report in here. And that is one of the reasons that we put the fixture, the vise, into our simulation, so that we could catch these collisions during the simulation of the CNC program rather than during the actual running of the program, because obviously that would be very costly in terms of destroying stock and destroying tools and damaging the CNC machine as well. So it's better to catch them in the simulation than to pass them on. So let's close that simulation down. So click there and click there to close it down. We want to go back into the profile milling sequence, so I'll select it and edit definition for the sequence. So we're back in the sequence now. So is there anything that we can do in here to tell the tool to avoid this fixture? Well, there is, and it's in the check surfaces tab. So if we click on check surfaces, it's waiting for some input or some surfaces that I want to use as check surfaces. So what I'm going to do is I'm going to select that surface. So I'm using the control key just to allow me to select multiple surfaces now. So that surface, that surface, that surface, and that surface. And basically what this does is it modifies the toolpath to avoid these specific surfaces. So if I click on the toolpath preview now, which is there, you should be able to see that the toolpath is now rising up and not trying to go through the vise fixture. So if I now run my simulation, so I'll click OK there and then go back to Op10 and run a materials simulation. I just want to run this through as quick as possible so that I can get to the collision report at the end. So run the simulation, turn the speed right up to the top. I may as well open the collision report now just so that I can spot if anything pops into there. And then just run the whole sim all the way through. So I'm still getting some collisions between my tool and my fixture or my check surfaces. And if I click on each one of these, I can kind of see where they begin, and I can kind of begin to surmise what the problem is. It's that the check surfaces haven't really been given any clearance. So the tool, when it does this blue path across the top of the check surface there is zero gap between the end of the tool and that top surface of the vise. So not only do I need to put check surfaces in there, I need to give the check surfaces some clearance or some breathing room between the tool path and the check surface. So let's just have a look at a few more of these. Yeah, we're hitting it on the sides as well. So I need to add some clearance between the tool and the check surface. But we've improved the situation. There's just a little bit more work in this profile mill to do. So profile mill, edit definition, if we have a look in the parameters, check surface stock allowance. That sounds good to me. So if I, just before I modify that, if I show my toolpath, so I click here, and then I can appreciate what effect my change here that I'm about to enter is having on the toolpath. So that's a useful way of working when you're experimenting with different values in your milling sequences. So let's try 3mm in here, and then I click out of the box to allow it to update. Yes, you saw the avoidance there that the toolpath was taking to avoid the check surface grew slightly. So if we want to appreciate that again, put it back to 0, and the toolpath shrinks back down to avoid the check surfaces. Put an offset of 3mm in there. Sorry, that's the wrong box. In there, check surface stock allowance, and there you saw the toolpath move. So if I click on OK, go back into Op 10, run a material removal simulation. Again, run this through as quick as possible, but open the collision report so that we can spot if any collisions happen. Click on run as fast as possible. Yes, no collisions are now detected. And what we could do conceivably is reduce that 3mm down and see at what point we actually get collisions. But if we're happy to give a little bit of an allowance that we will then have to machine away later on, then we can leave that at 3mm. So close the simulation down, and then on to our next sequence. Right, so now we're going to tackle the surfaces down inside the part that we previously left unmachined. So these curved surfaces down inside the reference model. So I'm going to hide the workpiece so that I can more easily access them. And I've already hidden the two extruded volumes that I'd created previously, the 2 mill volumes, so we'll hide those as well again. And I'm going to need to create a mill window like we did way back at the start of tutorial 1 when we kind of produced a silhouette of the part. So I'm going to create my mill window, but I'm not going to use the silhouette method to create this mill window. I'm going to actually sketch a mill window myself. So sketch the mill window, placement, window plane. I want this mill window on the top kind of surface that I've machined down to, so that surface there. And then in order to create my sketch, I've got to click on that sketch icon there, define an internal sketch, because I don't have a sketch already, so I'm going to have to define one internal to this mill window feature. So create a sketch. The system's then accepts the surface that I clicked on to create my sketch, but it needs a reference in order to orient my sketch properly. And I'm going to use the assembly plane right as my reference, and I'm going to tell it that should be over on the right hand side of my sketch. As it happens, I should have put left there, but it doesn't really matter. And all I'm going to do now is I'm going to kind of roughly create a corner to corner rectangle that kind of encompasses this area down inside my pocket or my cavity. So my cavity, you can see there in grey, that's kind of the lower portion of my reference model or of my mold. And then probably what it's wise to do is to try and tie the position of this rectangle to some edges relative to my part. So in order to do this, I have to go into references first, and I have to pick some edges in my part. So I'll pick that edge there. I might pick, I know that there's a flat edge over here, so I'll pick that one as a reference. I know that there's a little flat there as well, and I might pick, which is the widest point here, Let's pick that edge down there as well. So then I can close my references window, and then what I can do is I can put some dimensions between those references to my mold shape and my actual rectangle that I'm creating. So maybe I'll just have 1 mil offset there and 1 mil offset there as well. So I'm just making sure that my rectangle is just slightly bigger than the kind of cavity, the indent within my mold, like that. So it will entirely encompass it and just go slightly beyond the limits of it by 1 millimeter, like that. So the reason I bothered to do that is that if I change the design for my mold or change the design for my part, this rectangle will grow or shrink to accommodate the new design. So we'll click on OK. That is our mill window, so we want to tackle things which are within that window when viewed from above or when viewed from the perspective of the tool head itself. So I'm happy with the mill window, so I'll click on OK. I have my mill window in my model tree now, and with that mill window selected, I'm going to initiate a finishing milling sequence. So finishing, the system will try and fill in a lot of this input for me. The coordinate system, it's done obviously. The tool, it's chosen a tool from my tool table. As it happens, I want to go in here and I've already set up a bull mill. So these are the dimensions of my bull mill that I've created. If we just zoom into the head of that, it has a flat surface and it has a radius on the corner. So you can see that's 10 and 2 millimeter radius on the corner. So that's my bull mill. That's what I want to use, so I'll click on OK. In references, I already had the mill window selected, so it's accepted that as input here, but if I hadn't have pre-selected it, that would be empty and I could just click on my mill window and it will accept that. And then at this point I could generate a toolpath. However, before I do that, what I'd like to tell the system is that I've already machined away the material down onto this bottom surface. So if you remember earlier, we used the volume mill there, that volume mill, along with that mill volume that we'd already created to get rid of the material down onto that bottom surface. So from within here, I want to tell the system, don't machine away material on the bottom surface because it's already been machined. It doesn't need to be. So if I click in excluded surfaces and exclude the bottom surface there, and also this top surface, this blue collection of surfaces have also been machined to their finished size, so I can exclude those as well. So if I hold Control, I can select those two surfaces as saying you do not need to tackle these, they've already been machined to size, we're okay. So then if I want to generate a toolpath just to see what I've created there, and that is what my tool will do. So at that point I may want to see the material removal that will achieve, so I can click on OK and then go back to my operation level right at the top and simulate the material being removed. And I just want a really quick kind of run through of this. One thing that I have just forgot there is to make my workpiece visible again. So I'm going to have to quit out there, just make the workpiece visible and then do the same thing again. Material removal simulation. It may take it a few seconds just to calculate the simulation, just to get the simulation visible on the screen. Then I'll probably change this to be coloured by sequence and then turn the speed as fast as possible and just play that through. So that's what I'm going to achieve. So you can see it's taken some of the material off the sides here. It's left what are known as scallops. So if I get the angle correct so that we can see this, it's left a high point here. So the scallop is actually the low point, but whenever you get scallops, which are caused by the radiuses on the ends of tools, you will get a high point, which is further away from the finished shape than the other areas, the low points. So if I do a compare, you can see the high points of the scallops there pictured in blue. So what I might want to do at that point is to close that down, close the simulation down. Maybe I could go back into my finishing pass that I've just created. So go back in and edit the definition, show the toolpath, and the toolpath kind of gives a good indication of where the scallops might be. So wherever there's a line there will probably be a relatively low point, and then in between there will be a relatively high point. So with the toolpath visible, I can go into the parameters drop down and start modifying some of these parameters and seeing what effect they have on the finished part. So one of the things that I can modify here that isn't currently set is the scallop height that I would allow. So let's see what happens if I set that to 1mm scallop height. So when you press enter, it will take it a few seconds to calculate what the toolpath. So you can see the step downs in the toolpath have become finer. So I should see less effect of the scallops now. And then if I reduce that down even further, 0.5, and press enter, it will reduce the distance between toolpaths or toolpath heights even further. But I think for this particular one I'm going to leave it set to 1, because I'm intending to come back in here and do a second pass. So a second finishing sequence to address any high points or any scallops that I'm seeing. So I'll click on OK there, come back out to the operation level and run another sim and see how that's affected my excess material, or the bits between the low points of the scallops. So we'll turn the speed up. And then we'll compare. That's better, still not ideal. There's an area down in the bottom there that could be better. So let's come back out of there and then go back in and edit. And you very much end up working in this way of modify, run the simulation, assess whether you've had enough of an effect, and if you haven't, go back in and modify again. So it's an iterative kind of process. So show the toolpath, and I think this will be the last time that I modify this. So into parameters, maybe reduce the height down maybe to 0.8, and then I'm going to do one other thing here. So I'm going to put what's known as a finish stock allowance on here. So what this means is the system will try and machine to a shape or a set of surfaces which are going to be 0.4 millimeters smaller than, or further in than, the finished reference part shape. So when I press enter here, just watch the lines as they'll come inwards slightly. So 0.4 in there, press enter, watch for the lines. There, they moved inwards slightly. And the reason I did that, so if I OK that, is that what I'm intending to do is create a second copy of this finishing sequence. So the way I'm going to do that now is I'm going to say right click on the sequence, copy, and then if I right click there again, I get the option to paste a copy of that sequence. So click, and there you go, finishing sequence number 2. And what I'm intending to do in finishing sequence number 2 is in the parameters, I'm going to reduce the scallop height down to something very small, so 0.1. I'm going to get rid of any finished stock allowance, and then I'm going to preview the toolpath in here. So the thought is here, the rotational speed and the feed, and possibly even the tool type that you use in this original step, can be different to the speed and feed and the tool type that you use in this step here. So the first step is to do a rough material removal, and the second step here is to do a much finer kind of true finishing job, even though we are using the finishing type sequence for both of these. So I can put things like much smaller scallop heights in, I can make the tool cut to the actual finished reference model shape rather than leaving an offset, and I can modify cut feeds and spindle speeds as well. And as I've already said, if I really wanted to, I could go in here and I could use a ball mill rather than a bull mill. So let's see what that does to the step downs here, or the tool paths rather. So yeah, that's a much finer true finishing pass. So let's simulate what all of these look like now. But it's a good idea to separate out the bulk of the material removal, which can be done very roughly, and then the material removal when you are creating the finished surface on the finished part. So color by sequence, sequence list, fast, go. Yeah, so there we go. And that second finishing op has created a surface there which will undoubtedly be a lot finer and a lot nearer to the intended surface, the finished designed mold shape, than that sequence, the preceding one. So we're plotting it to within 1/4 of a millimeter plus or minus there. So essentially we've finished the internal surface of the part. So let's move on to one final sequence type, which is a drilling sequence, which is quite a simple sequence type. The tool doesn't really cut any material. Obviously when you're drilling, it doesn't even really cut any material in X and Y as such. The drilling sequences merely move to their drilling location and then drop in Z down into the part, and obviously drill the geometry. So let's say that we're going to create a standard drilling sequence. The tool's already been picked, so let's assume we don't have a drill in our menu. We would have to go in here, say I'd like a drill. At that point it helps if we know what size the hole is that we're intending to drill. I believe these holes are 10mm, but we'll check that in a second. And then let's set some kind of geometry for this tool. So I think that's enough to get this tool working. I didn't press new, so I should have pressed new there before I entered my dimensions for my new drilling tool in. So 10mm. So apply, OK, and then it's waiting for some input in the references tab, so I'll click there. There's various ways that I can select holes. If the holes have an axis running through the center, I can click on that, or I can click on some geometry, some cylindrical geometry. So I'll use the geometry option, and then I want to select that internal cylindrical face, but obviously the workpiece is getting in the way here. But I can use that technique that we've used before where I right click. So if I right click there, it allows me to click on the internal cylindrical face, click, and then the system finds the center of the hole itself. So drilling operations very simple like that. And if I had multiple holes in here, I could hold down my control key and do the same to the next hole and the next hole. If I just check the depth that it's going to drill to, so by default these drilling sequences set their own start depth and end depth, and in this case it appears to be drilling all the way through to the other side of the workpiece material. Now if I didn't want that, I could override this end depth and say I'd like to machine to a selected reference. Click, and then it asks me what would you like to machine to. And let's say I just want to go to the other side of the finished block, so maybe select that face there, and I could set the depth. You can see that it actually goes slightly beyond what I've clicked on, and that's because if you can visualize it, that is the tip of the drill. So the full diameter of the drill will just get to the end of the hole there. And then if I'm happy with that, I can run a simulation. So I'll click on OK, go back in here, run my material simulation again. Color everything by sequence, run the sim as fast as possible. So we're watching for the hole to appear in this corner. There it is. And then if we want to check what sort of depth that hole has gone to, we can cross-section the part. So let's find a plane which is sensible to cross-section it in. Here we go. And then we can use this drag bar to cross-section through the hole that we've created. So yeah, that looks largely correct. And then we can do a compare. Yep, the hole has been drilled to size. We can't look down into it because the tool and the holder are blocking our view, but we can hide the holder and hide the tool. Or maybe just hold the hide the holder, and then if we stare down into the hole, we can do a compare. So yeah, maybe it would be worthwhile going a little bit deeper with this hole, but we could do that. We could set the depth appropriately. So let's come out of there. So that's a good basic introduction to CNC machining in Creo. Obviously with this design there are areas that we haven't tackled yet. There are techniques for creating a second set of operations. So we did all this from a single set of operations, op 10 there, but there are options for simulating flipping this part over, for example, and clamping it in a slightly narrower set of jaws, and then tackling the second side of the part that we couldn't get to from this side. We'll not cover that in this tutorial, but with the techniques that we've learnt, by adapting them slightly or using slightly different tools for each one or different types of geometry, it should be possible to tackle the remaining areas that need some work in this particular design. So we didn't tackle the slots on the top, but you could quite easily use a milling window and some roughing techniques to tackle those. And we didn't tackle where to get appropriate speeds and feeds for your tools. But there will be a third video where we focus more in on where you would get your tool cutting data from, and we will use this finished manufacturing assembly as a dummy part to enter some of that tool data into.